Okay, so now we're going to go with pistons. And all I'm doing there is I'm laying them out 2 rows of 4 for the V8 engine. We'll go ahead and we'll weigh each one and record that weight. This one's 695, probably 695 and a quarter, because if you look at this scale, the half a gram light keeps coming on and then it goes back to 0 back and forth, so it probably actually weighs about 695 and a quarter. Here we had 696. $695 even, and if you notice I turned that piston 90 degrees. That has become my lightest. This one's a little heavier, 698. Okay, we have the third piston. This was our lightest piston. And this was our heaviest piston at 698. We're going to try something here. All I'm doing is swapping the piston pins here to see if that evens them out closer. Did not. Okay, so the lightest piston I have turned 90 degrees, and what we're going to do now is we're going to go ahead and we're going to lighten these pistons to 695 grams. Now, in order to accomplish that, I'm going to use the lathe right here. When I go to chuck the piston in the lathe, I get in the practice of, I look where the front mark of that piston is. And what I'm going to do is I'm going to set this in the lathe so that that front mark's pointing towards me, and I want the skirt in alignment where the chuck key goes in. Because what we're going to end up doing is we're going to have this piston in and out of the lathe a couple of times weighing it, and I want to put it back in the same position so everything runs true. So we'll get the lathe set up here a little bit. Let me grab a tool bit. You might want to look at this tool bit a little bit. The way I've ground this tool bit is that the tip has got a little bit of a radius in it. I seem to like that better for machining aluminum than I do a real sharp point on it. I like to leave a little bit of a radius in there because it also, I think, keeps, eliminates any place or maybe a fracture or a crack to develop. Now what I'm going to do to machine the piston is I'm going to set the automatic feed so it goes from me towards the middle of the piston. I don't want to feed out and maybe get into the piston skirt too heavily. Just kind of a safety precaution and also damage control. I keep an eye on how many thousandths I feed this in, and right now we're only taking off a total of 10 thousandths of aluminum from the balance pad area of that piston. That's going to become important, so you figure out how many thousandths to the gram, or how many thousandths to the half a gram. Okay, we're at 595 on that one by removing 10 thousandths material. We only have to take off a half a gram on this one. Okay, now here I'm putting that same piston back in, and this way it's going to run true if I match the way that I had removed it. Okay, this is the last piston. Remember that one that I only had a quarter of a gram to take out of? What happens if I would have taken off another gram instead of a quarter and gotten too light? That's when integrity comes into play. You got to go back and you lighten the other ones to match it. Okay, so we got the pistons done. Now we can go on to weighing rings, the bearings, and calculating the bobbler. Okay, we've got the pistons balanced, the weights recorded, so I'm going to put these back in the box, and then we're going to go ahead and weigh the piston rings and also the rod bearings. Okay, the rod bearings weigh 46 grams, so I'm simply going to write that down here. I'm still old school. I don't like to touch the bearing surface with my fingers and leave a print on it. And we're going to weigh one set of rings for one piston. And the weight of that set of rings is 58 grams. Okay, and after balancing the pistons, both ends of the connecting rods, weighing the rings and weighing the bearings, now we can go ahead and calculate the bob weight here. So let's transfer some of these weights over. I've written here the weight of the rings times 1. The weight of the rod bearings, we've got to do that times 2. Okay, the weight of the pistons from here. What I'm going to do, that's the piston and the pin. We don't have any pin locks. This isn't full floating, so I'm just going to kind of bracket that and put in 695 grams. And then the reciprocating end of the rod, that comes from this figure right here, reciprocating rod, 180.5. The rotating end of the rod was 403.5. So that would be 807. We have to multiply the rotating end of the rod by 2. We also have to multiply the rod bearing by 2 because we have 2 rotating ends of the connecting rod and also 2 sets of rod bearings on each journal. We're going to talk about balance percentages, and what we do with all V8 engines is 50% balance is what we call it. It's 50% of the reciprocating weight, 100% of the rotating weight. So we've got right here, these figures are 100% of the rotating weight that are going to be on the crankshaft journal when it's operating or running in the vehicle. We're taking half, or only 1 piston and pin, 1 set of rings for reciprocating weight, including the reciprocating end of the rod. Okay, and the oil allowance I'm going to put down here is 3 grams. And what we need to do now is we need to total these up. So what have we got here? We've got a 0.5. So we've got a bob weight of 1,835.5 grams. And now what we're going to do is we're going to make up some bob weights that equal this amount. And this is what we're calling a bob weight. We've got 4 of these for a V8 engine, and what we're going to do is we're going to make those equal 1,835.5 grams by using different weights of washers. These particular washers are 20 grams apiece. These thinner large diameter washers are 5 grams each. These small blue washers are 1 gram apiece. And then we have some small thin washers that are only ½ gram each. So what I'm going to do is I'm going to count out, well, let's go with like 15 of these just to start with. And when I'm making up this bob weight, I make these two stacks right next to each other. Because I want to make sure that I have the exact same number of washers on both of these stacks. Here we have 1835 and a half. For demonstration purposes, this kind of sucks because this is pure unadulterated luck. We wanted 1835 and a half. I guessed at 1520 gram washers. That's not skill. And we're at 1835 and a half. Now, we may need to work with these other washers on the other three bob weights. But I got to tell you, that's luck. Well, we'll go with 15 on each stack this time and see if we're just as lucky. We're at 1836 and a half. We've got some work to do here. So I'm going to remove two 20-gram washers, and now I'm going to take three 5-gram washers, and I'm going to put one of those, or three on each stack here. Let's try 4, see just what happens. 1835 and a half. Okay, we have a 1/2 gram calculation here that we're trying to come up with, 1,835 and a half grams. Well, so far we've been extremely lucky. We've hit that number right on. You won't always do that, and this is what I say. You want to hit the number exactly or be a 1/2 gram over. I'm going to say it's critical that each stack of washers have the same number on them. Now, I could have 1,835 and a half grams, but what happens if I had one of these washers over here? So this actually has, 2 extra washers, this has 1 less washer or something like that. You can still have the right number of grams, but if you have more weight on one side than the other, that's going to affect your balance job in the machine. So, we've got the bob weights made up now, and now we can go ahead and set up the crankshaft. Okay, we've got all of our bob weights made up now, so now it's time to put the crankshaft in the balancer and start that setup. First thing I'm going to do, though, is make sure that everything's clean and wiped off. You want to make sure that these bearings don't have any debris on it. We don't need to mess up the front or rear journal on the crankshaft. So these are going to be cleaned and oiled. I'm going to do the same thing to the crankshaft as far as making sure the front and rear journal of it are clean. All we need is a drop of oil on each of these bearings. I'd already measured the distance between the front and rear main journal and the crankshaft, and I set these two stanchions a certain distance apart. Very easy to accomplish. We've got a lock lever right here. This stanchion moves to the left or the right. This lever brings a nylon V-block down over the rear seal surface, so now when we spin the crankshaft, it's not going to move to my left or to my right. I'll just wipe off the rod journals a little bit where the bob weights are going to rest, just to make sure they're clean. Now, let me talk a little bit about these bob weights. Each one of these nuts is actually labeled with an A, B, C, D, so on and so forth, and so is the bob weight itself. And I want to make sure that I retain the proper nut to that proper stud on the bob weight. That's going to make our measuring job a lot easier down the road. And at this point, I'm simply clamping the bob weight on the journal. I'm not worrying about measurements at this point. I'm just getting all of them in position. One thing I do want you to pick up on or to notice, when I put the bob weight on the journal, that journal's vertical, pointing up towards the ceiling. And since I have this top stud pointing away from me to the back of the machine, I'm going to go ahead and put all of them on that way. Now the bob weight's representing the weight of the piston and pin, rings, reciprocating end of the rod, rotating end of the rod, everything that's going to be creating a force on that journal when the engine's actually rotating. Now, after I've got those on the crankshaft, the next thing I'm going to do is I'm going to get the numbers on each one of these nuts. If you can kind of zoom in on this. Let's see. Here you have a B, and then a line 2, a line 3, a line 4, a line. So these things are numbered all the way around with marks. What I'm going to do is adjust these so that I have the same reading on this side of the bob weight as I do over here. And what that's going to accomplish, it's going to get the gap between each half of the weights the same here as it is down in here. And that's extremely important. We want these bob weights, remember the washers I put on here, we want those going straight out from the journal. We don't want those going in a little bit of a V or a little bit of a pyramid type configuration. We've got to get them going straight out in order to do a real successful balance job. So I'm going to adjust these. So we have about the same numbers on each side. Okay, that gets us close. What I'm going to do now is I'm going to put this first journal, so the raw journal is vertical, and I'm going to set up this bob weight so it's, let's say it's 90 degrees to the stroke of that crankshaft. I like to do this. It gives us a better opportunity to repeat the balance job if we have to do something further down the road. Let's say they break a piston or a rod, or if something goes wrong with the engine. And then once I have that first one adjusted, I can adjust these other ones off of that first one. It takes a little more time, but it's time that I think is well worth taking. That kind of squares these up to the journals. The next thing I want to do is I want to space the journal or space the bob weight in the center of the journal, front to rear. So if we look at this first one here, so the gap here and the gap back here are very similar. Kind of twisted that last one. Okay. One more item that I like to do is I want to make sure that these washers, or the bob weights, are going straight away from each other. So I'm actually going to come back and measure them with some dial calipers. And I like to get these within 0.003. Not a tough job to do. Okay. Okay, we've got the bob weights on, we've got them set up. The next thing that we're going to do is we need to enter some measurements into our microprocessor here in order for it to pick up the information off the crankshaft to tell us what we have to do to make it within the tolerance we've come up with. So all we're going to do is use a tape measure. I'm going to start over here with this left radius. And what that radius is the distance from the center of the crankshaft to wherever this correction point is going to be around the crankshaft itself. And so I simply eyeball the tape measure to the center of the journal, and I'm going to put in here that this radius left is 3 inches. Then I'm going to come all the way down here to the radius right, and I'm going to do the same thing at this end. These aren't perfectly symmetrical counterweights, but they're so close, I'm going to enter the same number there. Now, actually has a drawing on the face of this machine, and the next correction is going to be from the center of this trunnion, or the center of this trunnion, to where we're going to correct the crankshaft. Well, for demonstration purposes, I'm going to measure from the inside of this counterweight to the center of that trunnion, and it's 2 3/4 inches. So on the left one, it's going to be 2.75. On this right one, going to be a little different. On the right one, this is going to be 2 inch. And then the last measurement I'm going to put in is this B, and it's from correction point to correction point. So I'm going to measure from the inside edge of the rear counterweight to the inside edge of the front counterweight, and that's 15 inches. Now, you might notice that we've got a green light lit up here where it reads in. We have a green light lit up here where it reads in. That has to do with these measurements here. What it's saying is that the correction point is inside this trunnion and inside this trunnion. That's how we're going to balance this crankshaft for now, how we're going to get the readings and make the corrections. After the crankshaft is finished balanced, it simply becomes a mandrel, and we're going to put the damper on the front end, the flywheel on the rear end. We're going to change these measurements, and then we're going to have the light that reads out lit up, because the damper is going to be on the outside of the trunnion. The flywheel will be on the outside of this trunnion. Okay? This is a little plastic degree wheel, and we're going to use this on the front of the crankshaft to tell us where we have to do the corrections. And all you do is you take a little piece of clay in the snout of the crankshaft, and then we're going to put this on, get it close to being centered. It weighs nothing, just a little plastic disc. And now what we need to do is have this photo eye so it's pointing at the piece of magnifying tape. I shouldn't say that. It's a tape that will shoot the reading back to it. We're to a point now where we can go ahead and start to spin the crankshaft. What I'm going to do very first off is I'm going to start the crank rotating, and I'm going to look at this RPM field right here. Make sure I'm getting a reading. If I'm not, it's telling me that the photo eye needs to be adjusted a little bit because it's not pointing right at that reflective tape. That's what I should have said earlier. Okay, and you can see here we have a reading. So our photo eye is working okay. And what I'm going to do now with this little rheostat is I'm going to adjust the RPM so it's spinning about, I shoot for all threes up there. I think we've got a little rattle with this laying down there. Okay. What we're looking at here is what the correction amount, both here, and the angle that we need to correct that. Let's start at the front of the crank since I'm closest to it. It's saying at angle 60, we need to add 26 grams. Well, if I rotate this disc so that 60 is vertical, this is where I need to add 26.7 grams of clay. Okay? Now, if this were a machine, which it has an accessory, you can have a drill press right here behind the machine. And since this is called a hard bearing machine, we could simply slide the drill press down, have this programmed to the remove, and it would tell us where to remove the weight from the counterweights. Here at school, and for this demonstration purposes, we're going to go ahead and add clay and fine-tune it with clay rather than just make the corrections right here on the machine. So I'm going to get about 27 grams of clay, and I'm going to set it 3 inches from the center of the crankshaft. That's important. Remember, we set this radius right at 3 inches. That's where I want to place the clay. I don't want to put the clay down here an inch from the center line. Then we're not going to get accurate readings up here. You're going to become frustrated and not like what you're doing. At the other end of the crankshaft, we have to add about 34 grams of clay. And the angle, remember the angle at the front was 60? At the back, it's 16. And we're going to put that clay at the 12 o'clock position. Now, once the crankshaft reaches and maintains an RPM, I said I was shooting for all threes. We're actually spinning at about 327 RPMs. And once it reaches that RPM and steadies out for just a moment, then we get a reading up here. This is telling me now that I need to add 3 grams at angle 73. Well, I can remember that the first angle was 60. Right here. Well, now it's changed where it's at 73. This is telling me that I didn't put the clay at the exact spot I should have. I'm going to move the clay from 60 degrees part way to the 73. So it's just going to take a minor movement here. At the other end, it says to add about 7 grams of clay at angle 33. Let's rotate this to angle 33 See where our clay is here? It's telling me I need to move it this way also. So I didn't put the clay in the exact spot I should have. This part though is, oh, it's a little bit trial and error. So I move this clay a little bit towards me, I move this clay a little towards me. We'll spin it up again and see if we improve on these readings. That's the name of the game, improving on those readings. Okay, we've improved it, not much, but we have improved it. At this end, we have an angle of 67 now and 2 grams. Well, if I set this at 67, I can still move the clay a small amount. I'm going to put another gram or 2 of clay on it as well as moving it. At the left side, angle 23, we need to put on about 3.5 grams. So I'm going to rotate this to 23. Here's your clay right at 12 o'clock. So I need to put about 3.5 grams up there. Okay, so far what we've been talking about, what you've been seeing is me adding grams of clay. Our tolerances are measured in ounce-inches of imbalance. For a street car, the tolerance is 0.5 ounce-inches. For racing purposes, it's 0.25 ounce-inches. We'll talk about that later on, about ounce-inches and that tolerance. Right now, all we need to do is change from our grams and push this tolerance button, and we're on the front, we're down to 0.05. Racing tolerance is 0.25, so we're 5 times closer than that. At the left end, even though it showed a couple more grams, we could correct that, we're down to 0.25 ounce-inches. So, you know, for the initial spin up of this thing, we're doing fine. I'm going to go back to the grams now, and I'm going to go ahead and do my initial correction. If you look here where the clay is, what I'm going to do is go 180 degrees across, find that spot on this counterweight. I'm going to mark it. We're going to weigh the clay on the gram scale, and then we're going to take that much weight out of the counterweight. On the front end, we have the same thing. We have our clay added to the journal side, so that means I'm going to take weight out of the counterweight side. So what I need to do now is get a piece of chalk here. And then we're going to go 180 degrees and mark it. And actually what I need to remove is 29 grams from that spot. Just going to make a note on it. Do the same at this end. Okay, we're going to take 37.5 out of this end. Now, if we could balance the crankshaft with clay, freeze it on there so it would stay for the life of the crankshaft, our job would be really easy. But what I need to do now is to move to the drill press and actually drill some weight out of this. So we're going to kind of turn things around here, and we'll do a little bit of drilling. Okay, we've got 29 grams weight that we need to take out of the front counterweight. I want you to take a look at this chart here, and this gives us a better idea of what diameter drill bit to use and also how deep to go. Across the top here is our drill bits in the drill bit diameters that we have. Over on this side is how deep we would go in inches, and then this whole grid is different amounts of gram weight. Well, I'm the type of person that doesn't like to drill just one hole, especially when we're correcting that much. I mean, we're just over an ounce of weight, so I'm going to drill 2 holes. So what I want to do is find out, if I drill 2 holes, what's going to equal very close to 29 grams for my initial correction. So if we came across here and I look down, let's say at the 5/8 drill bit, if I drilled down 5/16 of an inch, that's the solid portion of the drill bit is going to take out 12.2 grams. I need to look down here at the bottom though for the drill point. On a 5/8 drill bit, the drill point itself is going to take out another 1 8 1/10. So what we have here is 14 grams if I were to drill with a 5/8 drill bit and I went down 5/16 of an inch. So that's what I'm going to select to do. We're going to drill 2 holes 5/16 deep with a 5/8 bit. Okay, we need to take 38 grams out of the rear of the crankshaft. If I stayed with that 5/8 bit, 38, half of that's 19 grams. If I went down 7/16 of an inch with a 5/8 bit, the solid shaft of the bit's going to take out 17 grams. But again, it's going to take out 17.2 grams, and then the drill point is going to take out 1.8. That's 19 grams. So here we're going to use the 5/8 drill bit on both ends. We're actually going to drill 4 holes. We're going to drill 2 5/16 deep in the front, and we're going to drill 2 7/16 deep in the rear. Okay, let's go ahead and set this up in the drill press, and we'll make a correction. If you can see it in the video, what I have is I have the chamfer of probably a 1-inch drill bit already started here in the counterweight. So I'm going to use that. Now, this is the end that we wanted to take 38 grams out of, and what we've got right now is a pre-existing hole. I was going to go down 7/16 of an inch. What I'm going to do is kind of sneak over, look at that chart again, see how much deeper I need to go in this pre-existing hole. I'll be right back. Well, the chart told me that I need to go down a little bit more than 7/16 of an inch, so I'll go down like 15, 30 seconds on our gauge here. Lock the drill press in place here. I'm going to set the dial indicator so we get an idea of how deep we're going to be going. These are locked down. I want to protect the journals here from getting any shavings on them. So I'm going to cover the crankshaft with these rags to help with that problem. Okay, that's our 15, 30 seconds. And now I'm going to cut an equal distance on this side of the chalk line and drill our 7/16 hole. So I'm simply going to rotate it. Now I'm going to drill in just so the point or the flutes of the drill bit, the chamfer's in there. All I wanted to do is reposition the crankshaft a little bit so I get a straighter hole there. Reset our 0. And we'll go down 7/16 of an inch here. Again, I want to be careful not to leave any debris on that journal that's going to scratch it up. Okay, at this end, I got a little bit of a dilemma. You can see where the chalk mark is. It's to the edge of this pre-existing 1-inch hole. So what I'm going to do is I'm going to drill a 5/8 hole over here, and then I'm going to come over an equal distance and drill the other 5/8 hole. So these two holes are going to be a little bit further apart. Might affect the reading a little bit, but we can work through that. We've got the chamfer drilled into the chamfer, the drill bit, in the counterweight. So what we're going to do now is set the dial indicator at 0, and then we'll go ahead and drill down 5/16 of an inch. I'm going to need to reset the 0 on this dial indicator because the front counterweight on this particular engine, all 5.7 GMs, is not concentric. Not a big deal, just something you need to be aware of. Okay, I'm going to get rid of any burrs around the edge of that hole. Get rid of any debris off the counterweights or bob weights. And now we'll go back to the balancer and we'll respin this. Before I set it back in the balancer, I want to wipe off the front and rear journals to make sure that there's absolutely nothing on those. We'll replace our little plastic disc. Okay, at the front, we're at angle 66 now, and we still need to make a correction of almost 12 grams. All right, so I'm going to go ahead and we'll bring it in with that. 66. This is a good example if you can focus on where I put this clay. Remember, I want to stay at this 3-inch radius out here, and it's at angle 66. I don't want to put the clay down here because that's not 3 inches from the center line of the crankshaft. So what I need to do is to be actually putting the clay up here on the bob weight washers so we have a realistic number there. And then at the rear, angle 17, we need to change about 4 grams. Okay. Now you can see our grams are way down now, and our tolerance is looking pretty good, 0.16 and 0.09. Okay, so we need to make another correction on both ends here. Get my chalk out. .5 grams on the rear. And 12 and a half on the front. Okay, so we're going to go back to the drill press and make a little bit more of a correction here. At this end where we have the most correction to do, 12 and a half grams, you can see where the chalk line is. It's fairly close to that hole that I drilled. So what I'm going to do is I'm going to take 6 grams out of that hole, and then I'm going to take 6 grams out of another hole over here. And in order to do that, I need to look at the chart, see how deep I want to go with this 5/8 bit. Okay, we're going to go down just over 1/8 of an inch in the pre-existing hole, and we're going to be just under 1/8 of an inch in the new hole. Okay, we've got the chamfer in there. And we're going to go down about 100 thousandths. Boy, 2.5 grams. I'm going to use the pre-existing hole. We've got a 1-inch hole that was drilled at the factory. I'm going to go down inside there and take the weight out of down there. Quick check on how deep I want to go, about 60 thousandths. Okay, so now we'll go back over to the balancer, see what our correction did there. Okay, now gram-wise, we're down around a gram, gram and a half. Tolerance-wise, we're down well below 0.25. On the left angle, or the left end, we're at 0.12. On the right, we're at 0.17. So at this point, the crankshaft's balanced, and what we'll do now is we're going to put the damper and the flex plate on, and we're going to have to change these numbers down here a little bit in order to accomplish that. So let me go grab those two items, and we'll continue. Okay, we're going to take the flywheel or flex plate, we're going to put that on the rear. Then we're going to put the damper on the front. Now, you don't have to install the damper all the way onto the timing sprocket. What we want to do is set it on there far enough where it isn't going to come falling off. But we're going to have this off a couple times, correcting it probably. So we're only going to put it on part way. And now I just want to see if it wobbles. I might have to, yeah, it wobbles. Okay, now our correction points have changed from the counterweights to the damper and the flywheel. So we're going to have to do some measuring again. Let's start over here on the radius right. And what I'm going to do is I'm going to go from the center of the crankshaft out to this ring, the inertia ring. And what I have there is 3 5/8 inches. Okay, then the C measurement is going to be from the center of this trunnion to the inside of the damper. And that is 3 inches. Now, notice the light. I'm switching from being inside the trunnion to outside the trunnion. On the back, radius left, go from the center of the crank to these series of holes here is where I like to measure. So that's going to be 6 inches. Okay, and now from the left trunnion